everyone. So let us try to understand um, Robin karp algorithm step by step. So for to understand this, I've taken a simple example. Like my given text is 326 and my pattern is 26. So that in the second shift only we can match the pattern, and by that time we'll understand all the lines. So first is n equal to length of t. Uh, Given text is 3, in our case 326 3 length, so n equal to 3. M equal to length of p, which is 2. Our pattern length is 2. And then h equal to d power m minus 1 mod q. This hash we'll be using when we shift to the next. For example, first we'll compare 32. Since our pattern is 2 length, two digits we'll compare now. So first we'll compare this 26 with 32. If that is not matching, then we'll compare this 26 with one shift right. So from 32 to 26 we will be shifting. So when we shift from 32 to 26, this h we will be using, which is our last step. So here we will be using that hash uh, rolling function, we'll call this one. So that h formula is d power m minus 1 mod q. So q is a prime number. We are taking 11 in this case. We can take any prime number. And d is a mostly we'll take 10 only. That too for digit example numbers we are taking 10 only. Since 0 to 9 numbers are base 10, so we are taking 10. So m is pattern length 2. So 10 power 2 minus 1 mod 11. 10 mod 11 is modulation is mod value is remainder value. So 10 mod 11, 10, when we divide 10 by 11, 11 is not possible in 10, so 0, so remainder is 10. So our h value is 10. This value we will be using in the last step. So first in the Robin karp, first initialization we have done. N equal to length, m equal to length of the pattern, h equal to d power m minus 1 mod q. And then we need to compute the pattern hash value for our pattern. So our pattern is 26. So in the algorithm we have, after initialization we have p equal to 0, t0 equal to 0. This p will be used to calculate the hash value for our pattern. This t0 will be used to calculate the hash value for our text. First text we will be taking the 32, that one. So for I equal to 1 to m until our pattern length, in our case it is 2, we are going to calculate pattern hash. The formula is p equal to d into p plus p of I mod q. So our d is, we have taken d as 10. Here we are initialized in a t, since it is digits, we are having d as 10, q equal to 11, and then so we are applying here our p is pattern. Initially we have assigned p as 0, so we have 0, and then p of I, pattern of 1, I to 1 to 2. Since our pattern is length of 2, we are going to do 2 iteration, 1 and 2. So when initially I will be 1, when I is 1, the value is 2. 26, I is 1 is 2, I equal to 2 is 6. So first we are taking 2, initially p is 0 and d is 10. So 10 into 0 is 0 plus 2 mod 11. 2 mod 11 is 2 only. Because we can't divide 2 by 11. So the quotient will be 0 and remainder will be 2. When I equal to 2, the d value is 10 only, and we have p now 2. Initially it was 0. After one iteration it became 2, and then plus d into p we have done. P of I is p of 2. Now after the first calculation, iteration I will be 2 now. So 10 into 2, I value is 2. So p of 2, equal to 6 in this case. So 26 mod 11, p equal to, if we divide 26 by 11, 2 11s are 22 and remaining 4. So 26 mod 11 is remainder is 4. So our pattern value 26, that hash value is 4. Like this, we need to find, step 2 is we need to find the hash value for the our text. So we are calling this as one shift, one window. Initially we started with s equal to 0, and then we'll be shifting. So now we are going to calculate hash value for 32. So t equal to 0, t of p equal to calculated t value, and then we are calculating hash value for our 32 na. So here t of 1 and t of 2, in here if you remember we did p of 1 and p of 2 to match with this formula. Likewise in the below, when we calculate for our text, this is for pattern, t equal to d into t0 plus p of I. Initially t0 is 0 we have declared here, so uh, d into t0 plus t of I. So when I equal to 1, d is 10, we know, t0 is 0, t of I, t of 1 equal to, in our case, 32, na? So 3. So 10 into 0, 0, 0 plus 3, 3 mod 11, 3, when we divide 3 by 11, the remainder will be 3. And then now our t0 is 3. So in our formula, g into t we found 3, and plus our t of 2 is 32. So 3 we used here, 2 we are using now. So in 3, 10 into 3, 30 plus 2 mod 11, 32 mod 11. If we divide 32 divided by 11, then we'll get remainder as 10. So our hash value for our 32 is 10, like this. Yeah, but now we found the 10. 10 is not 4. So not equal to 4. Our pattern is not matching. Pattern 26 is not matching with 32. So here in the 9th step, we will be comparing P pattern to our TS, which is not matching. So we'll be skipping here. Next, now we did 32. Now again we are going to do with 26. When it comes to 26, it will be matching. That time we will be telling this pattern found valid in the shift 1. So first, now since it is not valid, we are going to increase s plus 1, and okay, before increasing, we need to execute this one. This is if we see here, before s increment only, this step also will be executed. So now s equal to 0, our length is 3 minus pattern length 2, 3 minus 2, 1. So 0 less than 1. Still we didn't complete our text comparison with the pattern. So we are shifting one side. So to shift, this is the formula. To remember this formula, we have a easy trick, which is like, so we actually initially we took 32, now we need to do 26, which means we can use the same hash value minus the hash value for 3 plus add the hash value for 6. So initially t of s0, so here we need to add t of s plus m plus 1. Our pattern length is 2. Initially 0 plus 2, 2 t of first 2 letters we have completed. Now we need to add one more letter, one shift. So t of s plus m plus 1, which is 6 we will be adding. And so if we see here, we are adding 6 for this value. And then we are going to minus the hash value for 3. So 3 into, initially we have calculated one h value, d power m minus 1 q, that value is 10. That value we are entering here. So we need to minus this 310, and the TS, the first window, what T we got 10, no, for 32. That so the current value 32 minus uh, uh, 32 this value, pattern hash pattern is 10. 10 minus 3 into 10 into our digit. So this one we remember like t of s plus m plus 1, the next digit we are adding, we are removing the hash value for 3. So once we solve this, so initially this 10 should be multiplied, digit should be multiplied with this term only. I did wrong. So after doing all these things, I have added, multiplied this 10. So this step is wrong. Don't do this mistake. So we'll be getting minus 194 mod 11. When we have my negative term, first we need to find the mod 11 for the positive term. For 194, the model function is like 111 or 11, and remaining 8, 4. So the remainder is 7. When we divide 194 by 11, we'll get 7. So this is for positive 194. For negative 194, this remainder we need to minus with our n. This is the formula. So when we do 11 minus 7, we'll be getting 4. This is actually a rule. When we have negative value, we can do like this. So after this rule, we are getting 4, which is matching with our pattern. So we are telling when s equal to 1, shift 1, we are fine. So when s equal to 1, we are telling this valid shift, that is our text is matching. So if we have one more 26 here, when s equal to 3, the value will, so number of occurrences, our pattern is occurred twice. Now in to have a simple example, I have taken this. So our pattern matched in when s equal to 1. When we shifted 1, it is a valid shift and we found one exact match. So this is how we need to remember the algorithm. So now if you see the algorithm, you can see like what is n, we know length m, and h we are using when we shift from 30 to 20 to 6. That time we'll be using this hash, and D is 10 in our case, and M is 2 and Q is 11. We have taken the prime number, and we are initializing this P and T0 for to find the hash value for pattern, to find the hash value for the first text window, and then for when I equal to 1 to M, until the pattern length, we are finding the pattern hash and the first text value. Then when we shift to next pattern, this text pattern, how we are finding with this formula. So if one until we reach the n minus m, if s is n minus m, we'll be calculating until we finish our length of the text. We'll be comparing, and for all the comparison, we'll check whether the pattern is matching with the DFS. If it is matching, we will say it is a valid shift. That means pattern occurs with shift yes. Okay. I hope you are getting. If we solve one more example, we'll be all right to remember this algorithm and solve the examples. Thank you.